Kobe. Ah, come on. Kobe. Ah, Kobe. Yeah. Alright, we're gonna try this instead. Let's just drop it into the water. Alright, to make sure that it's fully submerged, we're gonna use this part of the straw and push it in the water. As you can see, the volume is about 725 milliliters. Here I'm demonstrating the Archimedes principle, where whatever volume the object displaces is the volume of the object itself. This is more a science idea, but we'll compare it to how we find volume with math later. The basis of volume is similar to area, but instead of constructing 2D shapes out of squares, we're constructing 3D shapes out of cubes. Here is a base layer with 12 cubes, and we can stack it higher to get more layers to this figure. First, we'll be finding the volume of prisms, which is two shapes on each side connected by a series of rectangles to form the height of the figure. Here we show an animation of how the volume is stacking each respective figure. Notice the figure on the right is not a prism, it is a cylinder, which is simply a circle connecting each end. In the middle we have a triangular prism with triangles connecting each end, and on the left we have a rectangular prism with a set of rectangles connecting each end. Let's try to find the volume of a rectangular prism. Here we have the formula, which will be base, the shape we'll be stacking, times the height. The base is an area of a rectangle, so we just do length times width, which will give us 91. Then we see we're stacking this rectangle upwards. So the height, we'll stack it 9 feet high, which means we multiply our base of 91 times the height of 9 to get our volume of 819 feet cubed. This time we are finding the volume of a trapezoidal prism, which, as its name implies, means we are stacking trapezoids. First we calculate the base, which means we just find the area of the trapezoid, which gives us 246 feet squared. Next we stack it towards this inward direction, with our height being the 15 feet. To find the volume, we multiply our base times our height, which will give us 3,690 feet cubed. Notice I used 18 feet as one of the bases of the trapezoid. This is because opposite sides of prisms have the same values. The figures are congruent on each side. This is a cylinder, and its volume is similar to a prism in that we are stacking a circle instead of a polygon. So, to begin, we find the area of our base, which is the area of the circle. We find it to be 379.94 yards squared. Notice I used 3.14 to estimate pi. Next, we're stacking it downwards with this height of 26 yards. So we multiply our base and our height to give us 9,878.44 yards cubed. Now for the same prisms, let's discuss the surface area of the figures. Here we've taken part of cube, and there are 11 ways to do this. And if you add up the squares in each of these, the 6 squares will give you the surface area of the cube. When we take apart shapes like this, we find the net of the 3D figure, which is if we lay out each side in a 2D plane. Here we take apart a rectangular prism and triangular prism. Notice we can add up these 6 rectangles or these 3 rectangles and 2 triangles to find the surface area of these 2 figures. Let's try our hand at finding the surface area of a rectangular prism. So the formula is just the sum of the 3 areas of each set of sides. We have to multiply by 2 because each side is repeated opposite ends of the figure. For our first set, here's our area. This is the area of the second set and the area of the third. When we add them together, we find the sum of the areas to find the total surface area, which is 542 feet squared. However, let's take another look at the nets for these figures. Instead of looking at as the sum of individual rectangles, let's take the set of rectangles in the middle and just find the area for a single rectangle. We can do this for any prism or a cylinder. We just have to find the area of the rectangle in between and add it to the area of the bases on each end. Let's try to refine the surface areas with this new method. In this case, the rectangle in the middle will have a length which is equal to the perimeter of the rectangle on the bottom. So we take the height and then we will later multiply to this perimeter. We also will need to add the area of these bases. So we multiply the height and the perimeter, and then we add it to the bases, which will provide us with the total surface area. The surface area of the trapezoidal prism can be found in a similar manner. The area of the rectangle in the middle will have a length which is equal to the perimeter of the base, and the height will just be the height of this prism. Of course, we also need to find the area of the 2 bases themselves. So we find the area of these trapezoids. Then we take the area of the rectangle in the middle, which is the height times the perimeter, and then we add it to the area of the base to find our total surface area of 1587 feet squared. Now for a cylinder, let me unroll this paper here, where the length here is equal to the circumference of the circle, and this width will be equal to the height of this Clorox thing. And I use Clorox because remember to wash your hands and disinfect things. So, similar to our prisms, the surface area of a cylinder is we take this rectangle in the middle and we add it to our 2 bases. The rectangle in the middle will have a length, as I said, equal to the circumference of the circle, and the width will be equal to the height of this cylinder. We find those, then we find the area of the bases, which are just 2 circles. Then we add the 2 up to find the total surface area of the figure, which will be 2,555.96 yards squared. Before we move on to other figures, we introduce this concept of Cavalieri's principle. Here we are stacking triangles of the same area throughout the shape, and no matter how we bend the shape, it has the same triangles. Imagine this were a bunch of triangular prisms. This would be the sum of the same triangular prisms, therefore the entire shape has the same volume. We can further observe it in this image where as long as the base has the same area and the heights are equal, any prism or cylinder will have the same volume. It doesn't matter.
It doesn't matter what you think!
What happens in between, as long as the area in each section along the way is the same. Here's an example of the deck of cards. Notice that although The second picture, it's slanted. The third picture, it's all over the place. They have the same length and width for the rectangle on the top, and the height of the 3D figure are the same. Therefore, they have the same volume. Note that the surface areas are not the same, and Cavalieri's principle only applies for the volume of figures. Next, we're going to learn about the volume of pyramids. A pyramid is any 3D shape with a polygonal base and culminates into an apex, which is a single point. These are all pyramids here. Notice from the figure from the right that it doesn't matter what the base is.
It doesn't matter what you think! What? Wow!
As long as it's polygonal and builds towards a single point. The formula for the volume of a pyramid is 1/3 base times height. As the following two animations will show, pyramid is 1/3 the volume of a cube or rectangular prism. Note that Cavalieri's principle also applies to pyramids, therefore, no matter the slant of the pyramid, as long as the base has the same area and the heights are the same, the volumes of pyramids are equal. These two are examples of equal square bases and equal heights, but different slants, so the volumes are equal, while these show different shapes for the bases, but still same base and heights, therefore volumes are still equal. It is important to distinguish between a triangular prism and a pyramid, where a triangular prism has two triangles with rectangles between them, while a pyramid has a polygon and a single point with triangles between them. Here we compare a rectangular prism and a triangular prism with a cone, which is similar except as a circle base and culminates into a point. Note that as long as the bases have the same area, each subsection along the way will have the same area. When they culminate at the apex at the same height, then the volumes will be the same. Let's try to find the volume of this pyramid. We'll use the formula 1/3 base times height. The base is the square on the bottom, which we just use the formula for the area of a square. The height is simply 3. Note that it is perpendicular to the base, just as the base of a triangle is perpendicular to its height as well. Finally, to find the volume, we multiply 1/3 times the base times the height to get our final answer of 256 feet cubed. Now the volume of a cone is pretty much the same as the volume of a pyramid, except instead the base of a cone is the area of a circle. We know this works because of our good old Cavalieri's principle. So we find the area of the circle and we multiply by the height. Notice, however, for this cone, we don't have the height. Instead, we have what is known as the slant height, which is the 11.4. To find the height, we use Pythagorean theorem between the radius, the height, and the slant height and solve for the height. Now we have the height. We just plug in 1/3 times base times height to get our final answer of 147 pi or 461.58 meters cubed. Now let's visualize how to find the surface area of a pyramid. First, let's take it apart and look at its net. Notice that this is a square pyramid, therefore it is a square and 4 triangles. The formula for the surface area of a pyramid in your formula sheet is officially 1/2 times lateral length times perimeter plus the area of the base. If we take a look at this shading of the image, we see that the perimeter comes from the fact that the perimeter is also the sum of the bases of all these triangles. Then we simply add the base to find the total surface area. Let's try to find the surface area of this pyramid. First, we need to find the slant height, which we can find using the Pythagorean theorem using the height and half the base, or the side of the base. Applying the Pythagorean theorem, we find the slant height. Next, we find the perimeter of the base and also find the area of the base, which is a square. So we do s squared to find the area, and then we plug everything into the surface area equation to find that the surface area is 529.408 feet squared. As for cones, we need what is known as the lateral length, indicated here. If we find the net of the cone, we see that the lateral length looks like that. So working on this problem, the surface area equation is the same as that of a pyramid in that it is base plus pi r L. First we find the area of the base, which is the area of this circle, so we plug in pi r squared. Next, we see that we already have the radius and the lateral length given for this problem, so we just take those values and we can plug it into our final equation. For our total surface area, we then get 404.432 meters squared. Now we started off this video with me trying to throw the lemon into the water. So over here, let's try to find the volume of a sphere, which is what the shape of the lemon was. Here is the volume equation, and just for completion, let's do surface area as well. Both equations only rely on the radius, so as we can see the radius is 11, so here's how you find the volume. Here's how you find the surface area. Now if I put my lemon over here and then mark it, it's not very accurate, but I can try to measure the circumference. So let's put this right here and try to measure it. It's not very clear here, but it's about 19.5 centimeters. So let's try to calculate the volume with this 19.5 centimeters. We find the radius, we plug it into the volume, and we find that it is 125.34 centimeters cubed, which is the same as milliliters. And if we compare it to our original photos, we see that it is pretty close, because in this photo the difference is about 125. It was great knowing you and subbing for you all this year. I wish you all the best in the future. Don't let anyone bring you down or get to you like...
It doesn't matter how it makes you feel.
Peace.